Good day everyone, welcome to the world of actuarial mathematics. Today we will be discussing profit testing focusing on how insurers assess profitability for different policies. Before that, let us define first what is asset share. Asset share is the money left from a policyholder's payments after deducting insurance costs and expenses. To understand it more clearly, we analyze this by the given time diagram. We start with the asset share at time H plus the contract gross premium at age minus the expenses including the policy costs and death benefits at time H plus 1 while multiplying the adjusting factor for interest and survival probability. Asset shares are calculated retrospectively given by this formula. Now, this formula is crucial in finding the formula for the recursion relation for reserves. By substituting asset share to gross premium reserves given by this formula. In here, the probability of survival is equals to 1 minus the probability of death minus the probability of withdrawal. There are two kinds of asset share: the expected asset share and the actual asset share. Expected asset share is the amount of assets expected to receive, while the actual asset share is the amount of assets actually received by the insurance company.
Expected and actual profits play a crucial role in insurance, particularly in profit testing, which evaluates financial performance over time. Profit is determined by taking the accumulated reserves and cash flows at the start of a period and subtracting the reserves and cash flows at the end. This helps insurers assess financial stability and make informed decisions. For a set of n fully discrete policies, the total reserves at time H is denoted by n times HVG. So, the profit is influenced by inflows and outflows. Outflows are which the insurer must pay, including the death benefits, settlement expenses, and total reserves needed, while inflows are which the insurer receives, consisting of gross premium payments, fraction of premium paid for expense, and per policy expense. Expected profit is calculated using the projected values before the period begins, given by this formula, while the actual profit is based on realized values such as mortality rates, interest earnings, and expense given by this formula. So, in short, expected profit uses projected values, while actual profit uses realized values. The difference between actual and expected profit is known as gain or loss. A positive difference indicates a gain, while a negative difference signifies a loss.
So now, let's tackle the concept of profit testing. So, yung profit testing determines whether an insurance contract will be profitable before it is issued. So, yung purpose nito is to identify the profit which the insurance company can claim from the contract at the end of each time period. So, we now analyze the same type of insurance policy described kanina. We let n is equal to 1 so that profit for year H plus 1 can be broken down into two components: the surplus emerging that year and the change in reserve. So, yung surplus represents the excess of income over claims and expenses, while yung reserve adjustment accounts for the funds set aside to meet future liabilities. So, using this expected profit formula, PR sub H plus 1, we analyze whether the policy generates sufficient profit at each stage. And this allows actuaries to evaluate whether a policy is financially sustainable over its duration. So, to further understand how profit emerges over time, actuaries use profit vectors and profit signatures. So, yung first is yung profit vector, represents expected profit at the end of each policy year enforced at the beginning of the year. So, PR is equal to PR sub 0, PR sub 1, PR sub 2, PR sub 3, and so on. And this shows how profit develops annually, while yung profit signature accumulates profits across policy years adjusted for survival probabilities. So pi is equal to pi sub 0, pi sub 1, px pi sub 2, 2px pi sub 3, 3px pi sub 4, and so on. So yung profit signature reflects total accumulated profit for policies issued at the beginning of the year. So these measures help actuaries forecast profitability trends and make strategic decisions about product design and pricing.
So next is the example of profit testing given the following policy values of gross benefit reserve at time 0 equals 3,512, gross benefit reserve at time 1 equals 796, and gross benefit reserve at time 2 equals 941. So we will calculate the profit of the second policy year for 472 identical fully discrete policies. A 100% net benefit payable at the end of the year of death, mortality Q sub x equals 0.09, and an effective interest rate of 6%. Also, the renewable expense is also given, which is 200 plus the 5% of the premium. Assume the gross premium each year is G equals 10,194. So first, we denote the profit in second policy year as P sub R squared, which is equal to N, which is the identical fully discrete policies, multiply the quantity of the gross benefit at time 1 plus the gross premium, multiply the quantity of 1 minus the 5% of the premium, the renewal expense, minus 200 of the renewal expense, multiply by the quantity of 1 plus the interest, minus N, multiply by the quantity of death benefit times the mortality Q sub X, plus the survival function P sub X times the gross benefit reserved at time 2. So let's substitute the value. First is the N, which is 472. In the gross benefit reserved at time 1 equals 796, and multiply by 0.95 minus the 200 times 1.06 minus the N again times the quantity of 100,000 times 0.09 plus the complement of the survival function 0.91 times the gross benefit reserved at time 2 equals 941. And we will get the profit, which is equal to 491,261.38.
Moving on to assess profit, there are various measures that can be employed by basing on the profit signature. One of these is the net present value, which is the expected present value of future profits. The formula for NPV is given by this equation, where R is the discount rate and C sub K represents cash flows at each time period K. For example, consider a 3-year policy with cash flows and a discount rate of 5%. Using the formula and substituting the profit signatures and discount rate with the respective time, the net present value is now equal to 3,601. With this, we can say that the investment is profitable since NPV is positive. Another measure is the internal rate of return, or the IRR, where the discount rate at which NPV is equal to 0. Insurers often use this method as a benchmark, comparing it to the hurdle rate or required rate of return to assess investment profitability. If the IRR exceeds the required rate of return, the investment is considered profitable. When the cash flow has a sequence has a single sign change, a unique IRR exists. Otherwise, there may be multiple IRRs or no solution at all. Another measure is the discount payable period, or the DPP, which refers to the time that takes for an insurer to start making profit on a contract. Basically, what we have to do is to find the smallest value of M such that the NPV becomes greater than 0. For example, using the previous problem, if M is equal to 0 and calculating its NPV, it will yield to negative 3,548, which is less than 0. However, if M is equal to 1, NPV is now equal to 1,972, which is greater than 0. Therefore, the DPP for this example is equal to 1, meaning profitability starts after 1 period. And this metric helps insurers identify when their investments begin generating positive returns.
So we will now break down two financial concepts. First of all is profit margin, measures how much of the premiums collected turn into profit. The formula in simpler terms is profit margin equals to the net present value divided by the total expected value of premiums. So with example, we collected premiums of 10,194 for variable rates of 0.92 and 0.91 and a 5% interest rate. The total expected value is 26,868. Plug in that value to the formula for profit margin, we will get 13.4%, meaning for every peso collected in premiums, we will receive 13.4% profit. So next, NPV as a proportion of acquisition cost. What it means is that this shows how much return you get compared to what you spend. Formula in simpler terms is return ratio equals to the net present value divided by the initial cost. With the example with the 3,601 return, with the 3,548 initial cost, we will get 1.02, meaning for every peso spent, you get back 1.02 pesos.
Now that we have discussed the concepts, here we have a sample problem. If you need more time to analyze the problem, just pause the video. So for this problem, we will calculate the profit vector, the profit signature, as well as the net present value of the policy. So to solve for the profit vector, we will use the formula here. And then at time 0 for the profits, we have the initial expense of 155 given in the problem. So we will use that here. And at time 1, we have benefit at time 0, which is 0. Here we have gross premium. We'll just use that value. Here we have 0.05 as our commission. And then here we have 0.01 as our interest rate. Then we have Q sub 45. And then we have P sub 45. We take the complement of Q sub 45 there. And then we have our benefit reserve at time 1. That's how we calculate for the profit. And then we have here the answer. Then for time 2, we will just use the same. But notice we have 0.02 for interest here. And then we have different value as well here. As well as this one, Q sub 46 and P sub 46. As well as the benefit reserve here. Then at time 3, we have, in our problem, we have premium refund, wherein if the insurer, if the policyholder survives, the insurer will refund the premium with no interest. So we will multiply that with the probability of survival at age 47. So we have the values here. Then to get the profit vector, we will just list it like this. Then that's the profit vector. Then for the profit signature, all we have to do is to multiply the probability of survival at their respective times. So we have P sub x here and 2 P sub x here. Then we get this result, profit signature. Then finally, we have the net present value. When we use the values of the profit signature, then we discount it with the hurdle rate, 14%. So here we have the value for NPV, 5.08.
That is all. Thank you for watching.